Click the bell icon to get latest videos from Ekeeda.
Hello friends, so now let's start with a new topic called as inverse hyperbolic function. So we all have studied about the hyperbolic function and we know that hyperbolic functions are derived from hyperbola as we derive the circular function from circle. So now here we are going to learn about the inverse hyperbolic function, the different formulae of inverse hyperbolic function, and how can we use this formulae to solve the numericals. So now friends, what is inverse hyperbolic function? So I will explain this with the help of few formulae. So on the screen you can see that here I have written as sine h, here it is -1 and z. So we have seen the hyperbolic function. So in the hyperbolic function, let's say I want to write hyperbolic sine z. So we write it as sine hz. So here h represent the hyperbolic function. So whenever we apply the hyperbolic function on any angle, then we get some value. So let's say in this case that value is u. Now how do we find the inverse hyperbolic function? So I will shift this hyperbolic sign to the right hand side. So we will get z as hyperbolic sine inverse of u. So guys, this is the hyperbolic inverse function. So now here on this screen you can see that there are three different functions. So first one is hyperbolic sine inverse of z. Now the value of that is log of z plus under root z square plus 1. Now guys, you must be thinking, how did we get this value? So I'm going to show you how do we derive this value. So there are three formulae, that is hyperbolic sine inverse z, hyperbolic cos inverse z and hyperbolic tan inverse of z. So these three formulae, or I would say these three properties, we use frequently while solving the numericals. But guys, let me tell you that from these three formulae or these three properties, we can also derive the properties for hyperbolic cosec inverse z, hyperbolic sec inverse z, hyperbolic cot inverse z. So these are the three standard properties which we have to remember. But before that, I will tell you how do we derive these properties. So let's start with the first one. So hyperbolic sine inverse of z is log of z plus under root z square plus 1. So now guys, since we don't know the value of hyperbolic sine inverse of z initially, we will assume that value as y. And now my task is to prove that this y is equal to log of z plus under root z square plus 1, and then only we will get the formula. So since I have assumed that this value is y, to derive the result, what I'll do is I will take this hyperbolic sine inverse on the right hand side. So that will become hyperbolic sine of y. Now guys, we know the value of hyperbolic sine of y in terms of exponential function. So that is nothing but the Euler's formula. So it is nothing but e to the power y minus e to the power minus y upon 2. Now guys, why I am using this formula? Because if you see the formula of hyperbolic sine inverse z, then here the answer is log of z plus under root of z square plus 1. It means in the formula I should get log term. And to get the log term, I am taking the exponential function. So from exponential function, it is very easy to derive the log term. So guys, here we can say that z is e to the power y minus e to the power minus y upon 2. If we cross multiply, we'll get 2z equal to e to the power y minus 1 upon e to the power y, which is e to the power minus y. Now, by taking the LCM, here we'll get Now guys, we'll do the cross multiplication and we'll take all terms on one side. So here we'll get so guys, here we got the equation, or I would say here we got the quadratic equation in e to the power y. And we know the formula to find out the roots of quadratic equation. So here I'll find out the roots of this quadratic equation. So therefore that will be e to the power y equal to, now what is the formula? So the formula is like this. If let's say x is the root of the quadratic equation, we always say it minus b plus or minus under root b square minus 4ac upon 2a. So guys, I'll be using this formula. So here the value of b is 2z, or I would say minus 2z. So minus 2z minus, that is positive 2z, plus or minus under root b square, so that is 4z square, then minus 4ac. Here a is 1 and c is minus 1. So 1 into minus 1 into minus 4, that is plus 4 upon 2, because the value of a is 1. Now guys, here the square root of 4 is 2. So this 2 and this 2 we can take it common, and that will be cancelled with the 2 of denominator. So what we'll get? So from here we will get z plus or minus under root. From here we will get z square plus 1. So guys, here we got e to the power y as z plus or minus under root z square plus 1. So now we'll take log on both sides, so that here we will get y. Now guys, here the base of log is e, therefore this e and log e will be cancelled and we will get only y on LHS, which is equal to log of z plus under root z square plus 1. So y is equal to log of z plus under root z square plus 1. Now what was y? So y is the value of hyperbolic sine inverse of z, or y is equal to hyperbolic sine inverse of z. So I'll put this value there. So therefore we can say that hyperbolic sine inverse of z equal to log of z plus under root z square plus 1. And guys, you can see that I have derived the first result. So we have derived the first formula. So similarly guys, you can derive the remaining two formulae, and you have to memorize these two formulae for solving the numericals. So in this video we have covered the formulae and the definition of inverse hyperbolic function, which will be required to solve the numericals ahead. So guys, keep watching the videos, because in the next video I'm gonna cover the numericals which are based on inverse hyperbolic function. So keep watching Ekeeda, because here you will get knowledge about different engineering subjects like engineering mathematics. Thank you very much.